I was watching a video and someone asked a question about it, felling a large oak tree for use for lumber. They said it was different cutting for lumber than just normal tree removals. They started the cutting process and more or less they talked about they had used bore technique or plunge cut technique on trees before, but in this case they were not going to use it because it was going to be used for lumber. And then the back cut was started. As the tree starts to move, it's going to start to pull any fiber that's still attached. So I watched, and even wedges were put into the tree, the back of the tree, and hammered in. And you know, when people don't really understand a forward-leaning tree, there's no reason for wedging. The fiber that was still holding, in other words, it wasn't set up with a hinge. It was set up with still probably a third of the tree still holding as far as the fiber that was being cut. And the other reason was because the hinge was way too thick during the movement of the tree. So when that happens, you're going to get pulled fiber. Understanding that the hinge breaks from the back to the front, it has to be thin enough to allow those fibers to bend over and not pull. And then if it's too far back, the fibers tend to pull out vertically instead of bending over and breaking. But let's go back to the issues that really started it, and that was the lean of the tree. You see, if you understand how the lean works, then you can basically be able to use the proper cuts. The hinge can be set up and then the tree released from the back. That means that you don't have to chase the tree and no stressed fiber that you need for putting that tree into lumber. The video that I watched ended up with the tree went the right direction, but as it started to go, fiber was thicker in the middle than on one side. It wasn't equal all the way across. It ended up with long fiber pulls coming off of the back side of the hinge, as well as long fiber pulls coming out of the middle of the log. Any resistance, too thick of fiber, face notch closes, or possibly the direction's not correct, and you end up with the tree hitting another tree or catching a larger limb and twisting. That's what causes the fiber pull. It all comes down to that 5-point plan. We're not picking technique to be able to say, oh, that didn't work or this didn't work. It probably didn't work because of one or two reasons. So we look here and we think about, where is this tree leaning? And so pretty good size red oak tree, pretty good size canopy. And so we start evaluating our planning process, the 5 steps. Look at the direction of the tree. And you can see here from this vantage point, it's a fairly straight tree side to side. Taking the farthest limbs of the canopies to the left, farthest limbs to the right. Looking at 90 degrees to that position, about 10 to 12 foot of forward lean on this tree. We use a rule of thumb of about 10% of the diameter in thickness of the hinge and about 80% of the diameter in length of the hinge. We can't outcut the movement of this tree before fiber starts to pull or the tree tries to split. So we might cut half and half to reduce what we're chasing. In most cases, people would say, well, I need a 32 to 36 inch bar to cut this tree. But you probably still, with that chainsaw, could not outcut the movement before fiber is going to start to pull. The other one that you could use very simply on this tree to keep any pulls from taking place is a plunge or bore cut. With the long bar, I could go all the way through from the good side. With a shorter bar, I could cut a half or whatever I could reach from the bad side of the tree. And really all I've got to cut from the bad side is what I can't reach from the good side. And so in that portion I could use on this tree a 16 to 18 inch bar, cut half of it from the bad side, set up my 2.5 inch hinge, bore through on the good side, set up my 2.5 inch hinge, and cut backwards to the back of the tree. And more or less release that tree with a strap, we call it, in the back, and the tree would then move. And the hinge still working correctly, and probably even better, because that keeps that fiber from pulling and busting or splitting and losing control. And it also keeps anything from happening as far as fiber pulling from the back of the hinge that's too thick, too long. The only other determining factor that could be an issue would be the situation of the face notch not being open enough. In this case here, 70 degrees or more would allow that tree to go all the way down before you would end up with the face notch closing and any pulling fiber. Now, one thing that I can tell you on this tree, because of the canopy, when this tree hits the ground, you're going to have pull and twist. And so that tree's definitely going to flip to one side or the other. That's the thought process as we start to look at that. And so it's important to have that plan clear in our head and be able to execute it correctly. You know, whatever we do, usually we have some type of an idea of a plan. Maybe it's something we haven't done a lot of before, but then there's also the situation to where we have something that didn't go exactly right. We start off with a good plan, but then if something doesn't go right, it's kind of like, oh, well, nobody's hurt, let's get it cleaned up, we'll go from there. But if we really have a plan to begin with, and we come back and reevaluate what worked, what didn't, then we're able to really get better at what we do. It's sad, I think, sometimes I see people haven't had the opportunity to be exposed to, first of all, the planning process, and then the second is to reevaluate that plan and really figure out why we didn't get the results that we wanted to get. So whether you're felling a tree for cleanup, firewood, or for lumber, you want to make sure that you minimize the amount of pull and split at the hinge. That means your complete plan needs to really observe the leans of the tree, side to side, forward to back. If you do that, you're able to pick a tool out of that toolbox that's going to be able to give the proper release and limits the amount of loss of control and pulled fiber or split that can take place in the tree. So I appreciate you taking a look. Hopefully you picked up something. Leave us a comment. Let us know what you think. I know there's a lot of different experiences out there, and there's a lot of different ways to look at it. But the basics are the same. Tree fiber, no matter what species, is strong. It can pull, it can split. It's up to us as the operator to have the proper plan on what we need, how to execute that plan to get down to where we have a proper hinge and a proper face notch to reduce splitting and loss of control, pulled fiber, cracking of lumber, all of that kind of thing, so that then we can be able to work safer out there. There's not a tree out there that you can't in 30 seconds really put together a plan of what you can do on that tree. If you plan to cut it from the ground, definitely it's 30 seconds. It's going to take a little longer if your plan shows that you need to have the top taken out or removed, or you have situations of damage on the trunk or the fiber. That all comes into another variation of the plan. In most all situations, in 30 seconds, you can know whether you can do it and succeed, or you've got to go to a more intensive plan, a plan B. So thanks for dropping by. We hope to see you along the ForestApps Road sometime in the near future. And we wish you good sawing.